So today's topic is application delivery networking. In the data centers, application delivery is the key reason for having a data center, but we will define exactly what that means and how is it done. So there are application delivery controllers, what they are, and most of them are based upon load balancing. So what is load balancing? Network address translation, that is also used by load balancing and other ADCs, and then we go through lots of other ADCs. Alright, so five parts of this topic right now. So application and delivery in the data center, actually there is lot of what we call replication and partitioning. Depending upon the definition, some people would call it all load balancing, but we are going to distinguish here between the load balancing and partitioning. Basically, load balancing is done when you have a replication, when you have many copies of the same thing. So you have a server, you are running a web server, and you might have 4 or 5 computers doing the same web serving, because you have just a big website, a lot of users. That is the replication. And so when you have lots of servers doing the same thing, then you need to put a load balancer in front of it, and then the load balancer decides which server to send your request to. But then there is something which we call partitioning. Partitioning is when you want to divide the application into pieces, such that, for example, you take a YouTube application. Now YouTube not only serves the video, but also has a directory of all the videos, has your account information, has many other things. So it could have a different server for each of those pieces. In that case, there will be some box here in front of the servers. It will look at what is the request about. If it is about the video, it goes to server 1. If it is accounting, it goes to server 2, and so on. That is content-based partitioning. Context-based partitioning is that depending upon when and how and who did it, the request will go to a different server. For example, if it could be application context, for example, if it is a read, it goes to server 1. If it is a write, it goes to server 2. Maybe read server 1 is very fast, and write server 2 is good for writing, whatever reason, okay? And then user context. If it is a window user, send it to this server. If it is a Unix user, send it to that one. If it is a laptop user, send it to that server. So depending upon what the user is, what operating system they are using, what browser they are using, what is their context, you send them to a different server. For example, in particular, you will send a mobile user to a different server. I mean, you don't want to send an iPhone user to the same server that puts out this big page for laptop guys. Multi-segment. So now all of this, so you see now, understand the difference between replication and partitioning. Replication is when people are doing the same thing and you just want to do load balancing, simple load balancing. And partitioning is when you want to really know the context as to what is happening, either on the content itself or on the user end or the application end, and so on and so forth. In each of these cases, there are multiple TCP segments. So for example, if there is a ISP proxy, which is in the case of Google, there is a Google proxy, there is a TCP connection from the user to the proxy. From the proxy to the load balancer, there is another TCP connection. From load balancer to the firewall, if there is a firewall, from the firewall to the server, and so on and so forth. So even though it looks a single TCP connection to you, it is not end-to-end. Okay, it is broken at many places, which is totally transparent to you as a user. You send a request to connect to www.google.com. It is caught by proxy server at WashU first. And it says, I already know the answer to this question, so I'm going to send you the answer right away. And it doesn't even waste its bandwidth to AT&T to respond, to find that answer, right? So that is like ISP proxy or enterprise proxy, and so on and so forth. So then there are application delivery controllers. Actually, in this slide, I had already shown you lots of boxes. We call them middle boxes. Why they are called middle boxes? Because they are in the middle. Here is one end, there is the other end, and in the middle, right? So they are middle boxes, and another name or a better name for them is application delivery controller. It will become clear as to why we call them ADCs, but they're all middle boxes. The old name is middle box. because the original IP was not designed for this. It was designed just end-to-end connection, and later on people started putting middle boxes. You are thinking that you are talking to here, but you might be talking to a box over here, and this will be talking to that box, and this will be talking to that box. So there are many, many segments in between. In some cases, it doesn't have to go eventually to the server. Yes, it could go to the server, it could come back from the proxy. So we call it network service, a task that applies to multiple applications, such as security, monitoring, acceleration, offload. These things are not, they may not be application specific. Web server can use it, file server can use it. For example, login, okay? Many servers can use it. And so, intrusion detection and so on and so forth. So these are all what we call services, network services, which are really not specific to an application. I mean, actually, they would be used for a particular application, but they can be used for multiple applications. And therefore, several applications can share a service. All right? And the appliance that provides the service is called an application delivery controller. And so and the people who started selling it, in particular, like every time we talk about something, we talk about a company. So the virtualization was started by VMware, and they are still the leader. ADC was started by F5, and they're still the leader. So basically they call it ADC. So you could have a load balancing ADC, you could have firewall ADC, you could have proxy ADC, you could have SSL offload ADC. By the way, what is SSL? Yeah, secure socket layer. This is the one that you use HTTPS. I think we talked about that before. So the thing is, many applications use SSL. Not only HTTP, you have HTTPS, but there is FTPS, there is other applications that can use, and it's the same SSL. So you could have a box which can do that for all the applications. Alright, you already know firewall, proxy, and load balancer. Now, load balancer is an example of our ADC, but also the basic components of most ADCs. So this is going to be discussed in a lot more detail. Other ADCs are firewalls, reverse proxies, TCP multiplexers, and HTTP compressors. And we will discuss those slightly later. So the load balancing. The advantage, and this is why F5 came into business, is because the data centers were expanding and they could not do all the work on one server, so they were putting lots of servers. Once you put lots of servers, you need something in the front that can direct the request to different server every time. And the advantage of this is once you get this box, you can have 3 servers today, 5 servers tomorrow, 7 servers day after, and 3 servers day after that. You could change the number of servers. The customers don't know anything about that business. You don't have to have 3 addresses, 3 names, www1, www2, www3, and things like that. Just have one name. Alright, so it allows adding servers as needed. Now, on the server side, 2 terms are used that you should be aware of. Basically, one is called server cluster and server farm. What is a farm and what is a cluster? And from the name, it appears that the cluster looks like something small and farm looks like something big, right? And so that's what it is. A cluster is a centrally managed set of servers working together on one applications, and they appear as one server. So even though this is one server, this might have, not only 16 cores, but they could have 16 blades in it. So that is whole thing, one cluster. As far as we are concerned, it's just like one server. A server farm is a big room full of servers. And they could be working on different things, or they could be working on one thing, it doesn't matter. But their farm is, a big thing and generally independent. Server farm and server cluster. Then probes. So the load balancer, the way it knows that what is up, what is down, is that it sends a hello messages every so often to the servers, or ping messages to the server to figure out whether it is up or down. Those are called probes. Virtual IP, VIP, is the address to which the customers connect to. So the customer really don't connect to the server, they connect to the load balancer, and the IP on this side is what we call VIP, virtual IP. On this side there is a real IP, RIP. So VIP is the virtual IP, which is the customer facing IP address. Now you understand the term facing. Customer facing IP address. So load balancer has two IP addresses. One is customer facing, one is server facing. Every port has an address, right? So stickiness table. Now when a server connects you to one server, your first request, your TCP connection goes to server A, then you say, I want this data, you cannot send it to server B. That would be crazy, right? So once somebody has been connected to server A, all their TCP requests will have to go to that same server A. So the load balancer has to keep that state in a table somewhere that, okay, IP address X was connected to server 1, and therefore whenever IP address X comes in, we send it to server 1. That is called stickiness table. Not on that TCP connection. That would be crazy. That would really confuse, unless you do, so here's the thing, unless you do segmentation, in which case you really, the TCP connections are not going there, they are just ending right here, right? In that case, you can send one request here, second request here, third request there, because the customer doesn't know, right? But if it is if the TCP connection somehow, that is a mode 2, by the way. It doesn't have to end TCP connection here. It could just look at the message and send it, right? So in that case, it has to stick. And predictor is actually just the rule or the policy. This is just the rule or the policy that is used to balance, basically to forward. It could be simply round robin, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Least connections, or we keep track of how many connections are there. Hashing, which is random, or least loaded. This is difficult. I mean, least loaded would be ideal because we are load balancer, but then you have to manage every microsecond and millisecond what is the load on every server. And it's not worth the hassle. Now, I'm using these terms because these are the terms that are actually, I mean, there might be other names for it, but these are the terms that are used at least in one company's product. Okay, and again the leader, can you guess? It's not F5 in this case. It's actually Cisco's product. Okay, I mean basically Cisco is a networking guy, and in their product they use this thing. Anyway, so the names, in particular these names, predictor and the sticky table. VIP is general enough. Prof is a very general name, but at least. Anyway, so layer 4 switching. So now what does the load balancer look at? If it looks at only layer 2 to layer 4 header, we call it layer 4 switching. So it will look at your Ethernet address, source address, destination address, generally not. IP source address, IP destination address, and the TCP port number, source port and destination port. Alright, those are layer 2 to layer 4 headers, key header fields, and based upon those it could decide. It could be just one field, for example, the source IP address. That's it, done. But if you look at WASU has at the external end, maybe it has one connection. Somehow if it goes, if it's a big organization and it has only one, actually WASU is not a good example. But let's take a company in some other country which has just one IP address and 2,000 people behind it, or maybe 20,000 people behind it. There are a lot of requests coming from that IP address. Right? So then you need more than IP address to balance the load. Layer 7 switching is then when you look at more fields, which means include layer 5 through 7. And really in TCP IP world, we know that there is no 5 and 6. So this is layer 7. And so if you look up that, then there is layer 7 switching. Okay, if you want to send the video to this side and to this server, and you want to send the accounting to this server, you have to look inside the application field and see what it is about. You cannot just look at the TCP port number. I mean, maybe you can look it up if you have programmed it like that, but generally, they will be all connecting to youtube.com and port number 80. And now you have to go to inside that port number to figure out whether it is a video request or a directory search. So you look inside the layer 7 header or layer 7 event data, and that is layer 7 switching. If you want to do layer 7 switching, the problem is you don't see layer 7 until the TCP connection has been accepted. So first somebody says, okay, I want to connect to this server, and now you don't know which server to send because you don't know whether they are going to send video request or accounting request. So you just accept the connection. Who accepts the connection? The load balancer. The second time they say, okay, I want this video. Now you look at the video, you say, okay, it goes to server 1. Now we connect it to server 1. Alright? Now even though it might be a connection from you to them, but at least you know that you have sent it to server 1. So when the next time they request something or the second piece of the same video or the second frame of the same video, you send it to server 1. Or if they send a stop request, you send it to server 1. Even though there might be two TCP connections, but they are really connected. Alright? So the layer 7 switching requires delayed binding. Delayed binding means that we don't know the server until a application request comes in. Whereas in the previous case, L2 to L4 switching, you have immediate binding. Basically, you just pass the request and you're bound to that kind of server, right? Okay, if you need to do layer 7, it is better to just terminate the session and terminate the connection, which is segment, and then start a new segment. That way you can flip the other segment part as you want, as you need. Okay. By the way, this is the PhD topic of Subharti. So Subharti can tell more if there is a difference on this one. You agree with all this, right? So far. Yeah. So symmetric connection management. So now traffic in both directions passes through the load balancer. That is one option. And second is asymmetric, in which only passes one side and doesn't pass the other side. Alright, that creates lots of problems and so generally not used. But in symmetric case, once you send it to the server, server sends it to you and then you send it to the customer. Alright, even if it is layer 4 switching. See, in the layer 4 switching, you have the option of giving it to the server and the server can send it to whichever way they want. Right? But generally, even in that case, they send it to, and actually we have more slide on this one later on, just after this. So there are two ways of connection management, symmetric and asymmetric. In symmetric, both directions passes through the load balancer. In asymmetric, one direction passes, the other direction doesn't have to. So load balancing using DNS. What is DNS? Is the domain name system. So that is the first way people came up with the idea of doing the load balancing. So the way they did it was that when you go and ask for google.com, every time you went to the DNS, it will give you a different answer. Okay, so you will randomly go to some server, next time you go to some other server, next time you go to some other server. So that's the cheap and easiest way to do. You don't need any hard box or anything, just load name server. And so it gives you, but what it does is, what the DNS does is, and this is a standard DNS, is that every time it gives you a list, it rotates it. So that first time it will say, the DNS address is 201.202.203. Second time you go, it rotates it by 1 and says the address is 202.203.201. So what happens is most people will just take the first address and start. Alright? Third time you go, it gives you a different one. So in fact, after I printed your handout, I did something called NS lookup on www.google.com, and this is the answer I got. Okay, you see the list here. For the Google from my computer and my office, these are the addresses possible. All of these are www.google.com. And if I did it again second time, the list will be rotated and given to me. You can just check it out on your computer. What is the Mac command for NS lookup? Okay, so the thing is, I think NS lookup even might be a Unix command too, but this is on the Windows I did. NS is name server lookup. Okay, and you can put any name and it gives you the list. Alright, so rotating DNS is used for load balancing. The problem with this is that it doesn't know the geolocation of the server. So it doesn't know that this server, the second one, is in China, right? Or that this one is in India, or that one is there, so it doesn't know the geolocation. It doesn't know whether the server is loaded. It doesn't know whether the server is up. You gave the address on January 1st, and then you are asking on December 31st again. Who knows what happened to those servers, right? It doesn't have a server is up, and adding or removing a server is too slow, and DNS is too slow. What happens with DNS is everybody on the way caches the names. So when you ask for the google.com, it is not coming from Google. It is coming from the DNS in your computer first. If your computer doesn't know, it asks, the network DNS. If they doesn't know, then it asks, the site DNS. If site doesn't know, then it asks, blah, blah, blah. It goes all the way to the root. So there is a whole hierarchy of people, and all of them remember the previous answer. So they will all tell the old answer. Alright, so if you do change, suppose Google does give up one address, it will take months before the address will get out of everybody's DNS. Okay, talking about the DNS, there is an interesting story I need to share with you. So basically at one point, and this is old days, not now, one computer in Pakistan said, I am, and I think it was youtube.com. Okay, it resolved, if you ask for the youtube.com, it gives its address. So all the youtube.com requests went to that computer in Pakistan. Alright, so there was and suddenly this is like, youtube.com being attacked, which means they are not getting any requests. All requests are going into the drain. And so this was possible before. Now all the requests are authenticated. All the answers are authenticated. Responses are authenticated. So you couldn't, you could fool up to a certain point, but if you go beyond that point, you will get an authenticated answer. Okay, BGP, okay, alright, I got the answer. So it was because of BGP, because the BGP set the route to this address, which was youtube.com address. Address was correct, but in the wrong place. Now people are selling what they call global server load balancing. So you might have your application in many different clouds, many different locations. Each location has many servers. Each location has many balancers. Each of them have what we call virtual IP. And these are the real IPs on this side. So then you put this box, which is actually a DNS modified. This is a smart DNS. So when somebody sends a DNS request, it knows which of these are up and just only gives that list. That's all it knows. Somebody is up or down. And the reason it knows up or down is because it keeps sending the pings. And not only sending the pings, because this is designed by the company which is making all this, they could also put that this address is in China, this is in India, this is in USA. If the client is coming from USA, they will give this address. If the client is coming from China, they will give this address. So this is a smarter DNS. A specialized DNS server that keeps track of the server location and states. So there are two things they know. However, nobody will come to this DNS because they have their own DNS, unless they came to the basically authentic answer. If you don't ask for authentic answer, anybody can give you the answer whatever they know from before, right? But if you have just one company, inside the company you have just one DNS server, then this is the server and this will get to the right place. Or if it is one data center and this is the server, it will get you to the right place. Right place means it will divide your load the way you want it. So this is, while it is sold and bought and everything else, this is an appliance that is sold by some company. This is generally good for intra-company use. Okay? I think this answers your question. Your question was whether it is real IP or VIP given. So you say the name server only gives you VIP. And if you want it to be real IP, that doesn't matter. Don't put a load balancer and then the server will get it. Yeah, these are all VIPs. I think that was the same question he asked. Yeah, these are all VIPs. This is where you connect to. Now, given most applications the way they are today, I would be surprised that if it is a very small application, then you might just give a real IP. Because you really want to have lots of servers there at that address. Generally, we don't get. Generally, let me just say, see, the thing is, every statement I make is only 90% true. Okay? Generally, we don't get. But, there are applications. So here the thing, I use VIP in my home. So I have a server. And I ran into this problem, the server became hard, so I put another computer, then that became hard, then I had to put another computer. So every day I have to change the server. Finally it came to my mind that every time I change the computer, I should change its IP. So that I don't have to change everything else. And this basically that IP is used by security cameras. Security cameras use an FTP server to put all the pictures there, and you reprogram the computer and file servers and everything else. I mean, you have to reprogram everything for every time you change the server. So you give a VIP, and then whichever is the server that day, you use that VIP. So load balancing more. So now we know DNS part, but then we need to learn about something called NAT. NAT is network address translation, and there are three types of load balancing NATs. Dual NAT, server NAT, transparent mode NAT. But before I describe those three, I really need to explain to you what NAT is. So I'm going to the next few slides on NAT, and then after we are done with the NATs, then we come back to these three.